this video, we are going to now look at question 11 from Mathematics Paper 2 of 2022 for internal. Now let's look at 11a. The diagram below shows the points P 20 degrees north, 80 degrees east. Then our Q 40 degrees south, 80 degrees east. And R 40 degrees south and 30 degrees east on the surface of the earth. Take pi as 3.142 and radius 6370. Now we will have 3 points P, Q and R. Now let's look at the first question. Find the difference in the longitudes between points R and Q. So let's look at the difference in longitude. So between points R and Q. So R and Q. Now let's look at the longitude for Q is 80 degrees where east, and for R is 30 degrees east. Now we can see that the two longitudes are located on the same position. So since they are located on the same position, the rule is we need to subtract. So we need to subtract. So 80 minus 30 degrees, we get 50 degrees. So that is the difference in the longitudes between points R and Q. Now let's move on to Roman number 2. Calculate the distance PQ. So we want this distance PQ. Now this distance PQ is along longitude. So if the distance that you are calculating is along longitude, you need to find the difference in latitude. So let's look at the formula. So the formula is distance is equal to theta over 360 2 pi r. Then the theta will be the difference in the latitude. So let's look at the latitude for P. So latitude for P is 20 degrees north. Latitude for Q is 60 degrees south. So we have one latitude from north and the other one from the south. So this time we are going to add for us to find the difference. So we'll say 20 plus 40 will give us 60 degrees. So that's the rule, you add. So we have 60 over 360 times 2 times our pi 3.142 times the radius 6370. Now we can now do math. So 60 times 2 times 3.142 times 6370. So I'm getting 2,401,744.8 kilometers, then divided by 360. So what I just did here, I just multiplied the numerator part. So now we can divide by 360. So the final answer is 6,671.5 kilometers. So this is our final answer. Now let's move on to Roman number 3. Find the length of the circle of latitude 40 degrees in kilometers. So the formula for the length is the same for circumference. So circumference is equal to 2 pi r cos x. Then we'll say 2, our pi is 3.142, radius 6370 cos. So where there is x, you need to put the number of the latitude. So the latitude that we are dealing with is 40. So this is cos 40. Then we can now just do the calculations. So we have 2 times 3.142 then times the 6370 times the cos 40. So the final answer is 30,664.05 kilometers. So this is our circumference. Okay, so let's move on to question B. Question reads, the diagram shows a beam BCDE which was made by cutting off the smaller cone ADE from the cone ABC. Take pi as 3.142. Calculate the first one, the value of H. Now let's look at what is happening here. So here we have two cones. There is the big cone. The big cone is A, B, C. That is our big cone. Then the smaller cone is A, D, E. That is our smaller cone. So for us to find the value of H, we are going to use the principle from the similar figures. So what are we supposed to do? So what we are going to do is we are going to get we have the radius of the smaller cone divided by the radius of the larger cone. So that's what we are going to do. We'll say radius, I'll use a small letter r to represent the smaller cone over the radius of the larger cone. Then from there we are going to use now height of the smaller cone, small letter h, over capital letter H, height of the larger cone. Now what is the radius of the smaller cone? So the radius of the smaller cone is 3 centimeters. So we substitute, we have 3 centimeters over the radius of the larger cone is 8 centimeters. So over 8 centimeters is equal to height of the smaller cone. If we try to remove this cone, the height of the smaller cone is just this distance from F up to A. So this is 9 centimeters. So we have 9 centimeters over. Now the height of the larger cone, it is the height from point A up to this point here. So from point A up to here we have it's 9 centimeters. Then from this point up to here is H. So the height of the larger cone is H plus 9 centimeters. So that is H plus 9 centimeters. Then we are going to cross multiply. So here we have 3 centimeters. We multiply H plus 9 centimeters. Then here we have 80 centimeters times 9 centimeters. Okay, so if we want, we can expand or we can just divide by 3 so we can get the same answer. So let's first expand. 3 centimeters times H is 3 centimeters H plus 3 centimeters times 9, we get 27 centimeters squared, where the squared is coming from this centimeter and this centimeter. Now here we have 8 times 9. So 8 times 9, we are getting 72 centimeters squared. So here what we are going to do is we need to collect the like terms. So this will move to this side, giving us 3 centimeters H is equal to 72 centimeters squared minus 27 centimeters squared. So 3 centimeters H is equal to, so 72 minus 27, we get 45. So we get 45 centimeters squared. So we divide by 3 centimeters also here by 3 centimeters. So if we cancel, we get h is equal to, so this centimeter and this will cancel, so here we are going to have just 1 centimeter. Then 3 into 4 is 1, remainder 1. 3 into 15 is 5, so the height is the small letter h is 15 centimeters. Now for us to find the total height for the larger cone, we'll add, so we'll say 15 centimeters plus this 9 centimeters. What this means is the 15 centimeters is from G up to F. So this distance here, we've calculated this distance here to be 15 centimeters. So 15 centimeters plus 9 centimeters, now we have the actual distance for the larger cone. So this will give us 24 centimeters. Now let's move on to, but the final answer, the value of h is this one. That is the value of h. Now let's look at the volume of the bin. So the volume of the bin, we can see that the bin BCDE is a frustum. So what you are going to do is we need to find the volume of the larger cone minus the volume of the smaller cone. So let's look at the volume of the larger cone. Volume is equal to 1/3 pi r squared h. So these capital letters represents the larger cone minus 1/3 pi r squared h. If we want, we can factorize the 1/3 and pi, since it's common. If we want, we can just go direct. So let's just go direct. So 1/3, our pi is 3.142. Our radius for the large cone is 8 centimeters squared. Our height is 24 centimeters minus 1/3, 3.142. Then radius for the smaller cone is 3 centimeters squared. Then the height for the smaller cone is 9 centimeters. Okay, so let's look at let's do the math. So we can cancel 3 here is 1. 3 into 24 is 8. So we'll do 3.142 times 8 squared. 8 times 8 is 64, so times 64, then times another 8. So the volume of the larger cone is 1608.704 centimeter cubed minus, so we can cancel 3a is 1, 3 into 9 is 3. So here we have 3.142, then times 3 squared is 9 times another 3. So I'm getting 84.834 cubic centimeters. So let's subtract this now from the 1608. So minus that. So I'm getting 1523.87 centimeters cubed. So this is how we can find the volume of a frustum, which is a bin. So that's it for this video. Thanks for watching.